And welcome back to another podcast with Mr. Hagan. And on this econ podcast, we're going to continue with the production possibilities curve. We finished in the last video by graphing the production possibilities curve and identifying three areas created by that curve. And those were that was the area that was attainable but inefficient, the area that was unattainable, and then the curve itself, which was attainable and efficient. That's where we left off on the last podcast. On this podcast, we want to go back to our data, back to our production possibility schedule of guns and butter, and we have graphed already the guns and butter production possibilities curve based on this schedule. Caruso could produce 0 butter, 7 guns, 1 butter, 6.8 guns, 2 butter, and 6.2 guns, and so on down to 5 butter and 0 guns. And that's this graph right here. That's this production possibilities curve. What we now want to do is we want to now take that information and say, well, we want to say how many guns and butter will maximize Robinson Crusoe's utility. How many guns and butter will maximize his happiness? So what we're really asking, the fundamental economics question is, which one of these combinations of guns and butter will be the point of utility maximization for Robinson Crusoe? And to do that, we have to remember that decisions are made on the margin. So that means that we are going to have to find the marginal costs. Now, we're going to focus on butter. So we're going to say, what is the marginal cost? How many guns does Caruso have to give up for 1 more butter? What is the marginal costs of consuming butter? So let's go ahead and figure out those numbers. So let's say the Caruso is at 0 butter and 7 guns. 0 butter and 7 guns. So that's right here on the graph. 0 butter and 7 guns. That's right here. Let me just change my color up. That's right here. 0 butter and 7 guns. And now we want to say, what happens if Caruso wants some butter? So he's going to add some butter to his production. So he's going to go from 0 butter to 1 butter. Now, if he does that, he will no longer be able to produce 7 guns. He's going to have to reduce his gun production from 7 to 6.8. So how many guns is he going to give up by adding 1 more unit of butter to production? Well, he's going to give up, right here, 0.2 guns. He's going to go from 7 guns down to 6.8 guns. That's the marginal cost of producing the first unit of butter, is you have to give up 0.2 guns. Let's see that on the graph. Let's see what that looks like on the graph. He was here at 0 butter and 7 guns, and he wants to increase butter production to right here, to 1 unit of butter. But what we find is that 1 butter and 7 guns is unattainable. He cannot produce that. So if he's going to increase butter production by 1 out to here, then he will have to decrease gun production down to here. That's the 6.8. So he's going to have to give up 0.2 guns. That's the marginal cost right there. That's what he has to give up for the additional butter. So let's continue with that idea and say, well, what about if he produces 2 units of butter? What if he's now at 1 butter and 6.8 guns, and now he wants to produce a 2nd unit of butter. So he's going to add 1 unit of butter to his production. Well, what happens then to guns? Well, he'll have to decrease his gun production from 6.8 down to 6.2. So his marginal cost of just the 2nd butter is 0.6 guns. That's his marginal cost. That's his marginal cost. By the way, let's calculate total cost. If he produced 1 unit of butter, his total cost in terms of foregone guns, in terms of guns given up, is 0.2. If he produces 2 units of butter, then the total cost is, well, he gave up 0.2 guns for the first butter, and he gave up 0.6 guns to produce the second butter, he has given up a total so far of 0.8 guns for 2 butters. How about for the third one? By the way, let's go do that on the graph first. If he adds a second unit of butter goes from 1 to 2, then he has to give up 0.6 guns. Okay, that's the concept. Add some butter, have to give up some guns. Add some butter, have to give up some guns. Let's continue the whole way down. If he produces 3 units of butter, he added 1 butter, he has to give up 1.2 guns. Total cost is then 2. See, the total cost is just adding up all of the margins. The total cost is just adding up all of the margins. Gun number 4, to go from 3 to 4, he has to give up, it would be 1.8 guns. Total cost is now 3.8. And then finally, if he wants to go to producing a 5th gun, that's adding, or a 5th butter, that's adding 1 more butter, he has to, give up 3.2 guns. Total cost is 7. Let's see all of those on the graph. So on the graph, we're back here on the graph at he's producing 2 butter and 6.2 guns. Now he's going to add 1 more butter, and he had to give up, I think it was 1.2 guns. And then he adds another butter, and he has to give up, I think it was 1.8 guns. And then for the last butter, to go from 4 units of butter to 5 units of butter, he had to give up 3.2 guns. So here's the marginal cost on the graph, which is really a slope concept. I'll say that in a second. And here's the marginal cost over here on the chart. Let's do a quick graph of that. So we want to take these marginal costs and we want to graph them. So I put butter on the horizontal axis. I put marginal benefits, marginal costs on the vertical axis. These are measured in guns, how many guns you have to give up for more butter. And let's see, for the first butter, the marginal cost was 0.2. So we graph it. Second butter, marginal cost was 0.6. And by the way, you can also get those by going back and looking at it here. First butter, marginal cost was 0.2. Second butter, marginal cost was 0.6. And so on. Third butter, marginal cost was 1.2. Fourth butter, the marginal cost was 1.8. And the fifth butter, the marginal cost was 3.2. Connect the dots. And you have a marginal cost curve. There's your marginal cost curve. So the marginal cost curve is really just graphing the slope of the production possibilities curve. It's really just graphing the slope of the production possibilities curve. It's the change in the butter compared to the change in the guns. Okay? The marginal cost curve is derived from the production possibilities curve. Now, we still have not answered the question. What amount of butter? What combination of guns and butter maximizes his utility? Sorry, it should be right here. What combination maximizes his utility? We will deal with that on the next Econ podcast. Thanks for joining me. This has been Mr. Hagan. See you on the next podcast.